if you see an X in front of the minus sign, then it's going to open horizontally. Horizontally. This is your answer. And if there was a Y in front of the minus sign, it would open vertically. To find the center, multiply these numbers by -1. So what's positive 2 times -1? -2. And what's -2 times -1? Two. Since this was with X, I'm going to be using this number as my X coordinates. And since this is with Y, I'm going to use this number as my Y coordinate. This is your answer. How do we find the vertices? Well, you need to find A. And this number, that's A squared. The denominator in the first fraction is A squared. The denominator in the second fraction is B squared. So we know A squared, but we're interested in just A. We're just interested in A. So what should we do to 4? So to go from here to here, I had to take the square root of the left-hand side of the equation, which means to go from here to here, I need to also take the square root of the right-hand side of the equation. So what's the square root of 4? 2, because 2 times 2 is 4. Okay, so now that we have A, we can find the vertices. Since X is in front of the minus sign, we're only going to be changing X from here. So only change the X coordinate. This is going to stay the same. Okay, so how are we going to change the X coordinate? So we're going to add A to it. So what's -2 plus 2? -2 plus 2 is 0. Now we need to subtract this from -2. So what's -2 minus 2? -4. This is your answer. With foci, it's the same idea as vertices, except instead of using A, you need to use C. What's the formula for C? With the hyperbola, the formula for C is the square root of A squared plus B squared. And what's A squared equal to? A squared is equal to 4. So let's go ahead and change A squared to 4. And what should we change B squared to? B squared is equal to 16, so we need to change it to 16. What's 4 plus 16? 20. And I'm going to rewrite square root of 20 as square root of 4 times square root of 5. Why am I doing this? Because I know that the square root of 4 is a whole number. It's equal to 2. So that's how we simplified this radical. So C is equal to how much? 2 root 5. Okay. And we just need to repeat our steps for the vertices, except instead of using A, we need to use C, so 2 root 5. Okay, so Does the x-coordinate or y-coordinate stay the same? Since x is in front of the minus sign, we have to change x. So the y-coordinate stays the same. Okay. So repeat our steps. What did we do to figure out the vertices? What did we do with -2 and a? So to get this, I subtracted. No, wait, I added. I added -2 and 2 to get this. I subtracted -2 and this to get this. Okay. So that means I'm going to add this and this to get what's over here. So -2 plus 2√5. I also need to subtract. So -2 minus 2√5. To find the transverse axis length, oh wait, I forgot to box this. This is your answer. To find the transverse axis length, use the formula 2a. So 2 times how much? How much was a again? A was 2. What's 2 times 2? 4. This is your answer. To find the conjugate axis length, use the formula 2b. We don't know what b is, but we know what b squared is. How can we figure out b? Here's a hint. Repeat what we did here. So to go from here to here, I need to take the square root of this side of the equation, which means to go from here to here, I need to take the square root of 16. And the square root of 16 is just, well, how much is it? The square root of 16 is 4, because 4 times 4 is 16. So I change b to how much? Change b to 4. What's 2 times 4? 8. This is your answer. To find the lattice rectum length, use the formula 2b squared over a. How much was b squared again? B squared was 16. So change b squared to 16. And what should we change a to? A is equal to 2. How do we simplify this fraction? Well, there's a 2 on top and a 2 on bottom, so we can just cross them out. So we're just left with 16. This is your answer. To find the eccentricity, use the formula c over a. How much was c again? C was 2√5. How about a? 2. How do we simplify this fraction? There's a 2 on the top and a 2 on the bottom, so I can just cross them out. And we're just left with √5. Okay. To find the asymptotes, use the formula y equals b over a times x minus h plus k, and the other asymptote is y equals negative b over a times x minus h plus k. What was b again? B was 4. Okay, so we're just going to plug in B, A, H, and K into here, and I'll walk you through it. But we're going to change B to 4 over, A was how much again? 2. And H, that's this number. So x minus -2 plus K, which was what number? So this is H, this is K. Yeah, so you have to go to the center for H and K. 2. And then you'll notice that to go from here to here, the only thing that's different is the minus sign. So to go from here to here, we're just going to tack a minus sign in front. Y equals -4 over 2. X minus -2 plus 2. Oops, I forgot a parenthesis. Okay, and we can simplify some stuff here. What's 4 divided by 2? 4 divided by 2 is 2. Subtracting -2 is the same as adding how much? It's the same as adding 2. Okay. How about this one? So keep the minus sign. 4 divided by 2 is 2. X minus -2. That's the same thing as just adding 2, and we keep the 2 at the end. This is your answer. Let's go ahead and graph this. So we'll graph the center first. So where was the center again? -2, 2. So -2 and then 2. Next, we need to graph the vertices. So where were the vertices? 0, 2, and -4, 2. So 0, 2, and then -4, 2. Okay. And since this graph opened horizontally, we moved A units to the right and A units to the left of the center to find the vertices. So graphically, what does this look like? So I moved A units this way and A units this way. But also, since we're moving A units left, A units right, we're moving horizontally, but we also need to move vertically to graph the hyperbola. So I'm going to move up by B units. B was how much again? B was 4. So move up by 4 and down by 4. So if I move up by 4, where would the point be at? So here, I'm at 2. I need to go up by 4. So 2 plus 4 is 6, and that's going to land me right here. So I go up B units. I also need to go down by B units. So what's 2 minus 4? -2. Okay, now I'm going to turn this into a rectangle, and I'm going to explain why in a second. I turn this into a rectangle because it makes graphing, I should probably say this is B units long, but it makes graphing the asymptotes easy. So the first asymptote is just going to go through the diagonal, like this, and the second one's going to go through the other diagonal. Uh-oh. It's okay to not be perfect. Okay, so these are your asymptotes. These are the lines that the graph will get very close to touching. Very close, but it will never touch. So what do I mean by that? So remember, this was the vertex and this was the vertex. Why? Because the graph opens horizontally, and if it opens horizontally, I'm gonna graph it like this. You can see that this thing opens horizontally. So that's why this is a vertex. And this is also a vertex. We're opening horizontally. We're getting close to this line, but we're not quite touching it. Okay. And that's how to graph these. Oh, also, if it opened vertically, then it wouldn't look like this. It would look very different. You wouldn't be going left and right by A, you'd be going up and down by A. But I'll do another example with a graph that opens vertically. Let's go ahead and graph the foci, the transverse axis, the conjugate axis, as well as the latus rectum. So we'll start with the foci. So we need to plot these 2 points. And you can use a calculator, but this is approximately 2.5. So we'll just graph 2.52. And this is about -6.5. So 2.52, -6.52. Let's plot these 2 points. Okay, 2.5. So this is about 3. This would be 2.5. And then we go up to 2. So right here, that's one focus. That's our first focus. And our second focus, -6.52. -7, -6.5, and then go up to 2. So these are your foci. Okay. Next, we need to graph the transverse axis. So the transverse axis is this line segment between the 2 vertices. That's your transverse axis. Okay. How about the conjugate axis? The conjugate axis is this one. How long is the transverse axis? How long is this in terms of A? So I need to move A units to get from here to here, and then another A units to get from here to here. So in total, how many units did I move? How many A? So in total, I moved 2A. So that is why the transverse axis length is 2A. How about the conjugate axis? How long is that? 2B. Yeah, so that's why the conjugate axis length is 2B. What's the latus rectum? So to find the latus rectum, you need to go to the foci. And I'm going to start at this focus, and I'm just going to draw a line parallel with the conjugate axis. So it has to be parallel to this that goes through this point. What would it look like? So it would look like this. And once we get to the hyperbola, that's where we stop. So this is your lattice rectum. Okay, and this is another one. It's not perfect. It's okay not to be perfect. These are close enough in length. I'll explain why the lattice rectum length is 2b squared over a in another video. But yeah, I'll explain why all these formulas work in another video, but yeah, let's move on to the next example. Here's what to do if it opens vertically. First off, why does it open vertically? Because y is in front of the minus sign. This is your answer. So with the xy plane, this is the x-axis. So when we think x, we think horizontally. When we think y, we think vertically. Since y is in front of the minus sign, it opens vertically. Okay, how do we find the center? Well, I'm going to rewrite this equation like this. So the first fraction is going to stay the same. But the second one, I'm going to rewrite it like this. So x plus 0 squared is the same thing as x squared. I'm also going to divide by 1. This is still the same as this. And then equals 1. Now this looks like something we're familiar with. How do we find the center? So we need to multiply this number and this number by how much? By -1. So -2 times -1 is how much? 2. 0 times -1, 0 times -1 is how much? 0. We need to be careful here. Since the 0 is with x, I'm going to be using 0 as my x coordinate, and I'm going to be using 2 as my y coordinate because it came from the same fraction as y. This is your answer. How do we find the vertices? Do you remember? So to find the vertices, you need to find A. How did we find A again? What's this number? This number, the denominator in the first fraction, is A squared. So to find A, what did we do to both sides of this equation? We had to take the square root. We take the square root to go from here to here, so we need to take the square root of 4 as well. What's the square root of 4? 2, because 2 times 2 is 4. Okay. And since y is in front of the minus sign, do you think we should change x or y? Since y is in front of the minus sign, we need to change y this time. So x is going to stay the same. Okay. And what should we do with this number and this number? So we add them to get this, to get what goes here, and then we did k because this is h, this is k. So k minus a to get what goes here. So what's 2 minus 2? 0. This is your answer. How do we find the foci again? What was the formula for C? The formula for C was the square root of a squared plus b squared. And what number was a squared again? So this number is a squared. Yeah, a squared is 4. So let's go ahead and change a squared to 4. And what should we change b squared to? So this number is a squared, and this number is b squared. So change b squared to 1. What's 4 plus 1? 5. Can we simplify this radical? Well, no, because no perfect square other than 1 evenly goes into 5. So C is root 5. Okay, so how do we find the foci again? Since y is in front of the minus sign, we're only going to be changing y. So this is going to stay the same. And it's the same process as the vertices, except instead of using A, we're using C. So how did we find this again? It was this plus this. So this time it would be this plus this. And then for this one, how do we figure it out again? It was k minus a. So this time it's going to be k minus c. This is your answer. To find the transverse axis length, what formula did we use? We used the formula 2a, so 2 times a, 2 times 2. How about the conjugate axis? What formula did we use for that? We used 2b. And b was how much? How did we figure out b? So b squared equals 1. What should we do to both sides of the equation to figure out b? We need to take the square root of both sides of this equation. So square root of b squared is b, square root of 1 is just 1. So change b to how much? Change b to 1. Change b to 1. What's 2 times 1? 2. This is your answer. What was the formula for lattice rectum length again? The formula for lattice rectum length was 2b squared over a. How much was b squared again? B squared was equal to 1. So change b squared to 1. How much was a? A is equal to 2. How do we simplify this fraction? There's a 2 on top and 2 on bottom, so I can just cross them out. How did we find the eccentricity again? What formula did we use? We used C over A. How much was C again? C is square root of 5. How about A? A is equal to 2. Can we simplify this fraction? There's nothing to cross out, so no. Now, to find the asymptotes, with a vertical graph, it's a little bit different. The formula is y equals a over b times x minus h plus k, and y equals negative a over b times x minus h plus k. You'll notice the only thing different here, when going from here to here, is that we added a negative sign in front, just like our previous example. So let's go ahead and plug in a, b, h, and k into this. So it's going to be y equals, how much is a again? 2. B was how much? B was 1. How about h? How do we find h and k again? We need to go to the center. So this number is h, this number is k. So change h to 0 and k to 2. Okay, and this one, I just need to tack a negative sign in front. But we need to simplify these equations. What's 2 divided by 1? 2. X minus 0 is the same thing as just x, and then keep the plus 2 at the end. What does this equation turn into? Oops. It's going to turn into y equals negative 2x plus 2. This is your answer. Let's go ahead and graph this. So what did we graph first in our previous example? We graphed the center. So the center was 0, 2. So we need to go to 0, 2. So 0, 2. What did we graph next? We graphed the vertices. And the vertices are where? 0, 4 and 0, 0. So 0, 4 and 0, 0. Remember, to go from the center to the vertices, you're moving by a units in each direction. Since we moved a units vertically, we need to move b units horizontally now. So this is a little bit different from our previous example, because in our previous example, when x was in front, we moved a units horizontally. But now we're moving b units horizontally. So just make a mental note of this. And b was how much again? Remember, to find a, you can just look at the denominator in the first fraction. To find b, you can look at the denominator in the second fraction. You have to take the square root though, right? A is the square root of this. B is the square root of this. So b was 1. So that means we need to move 1 unit to the right So I'll just say B here. Oh, this, I could have done better with this diagram. And then 1 unit left. And then what did we do? We drew the asymptotes. But before drawing the asymptotes, what did we do? We drew a rectangle. What do the asymptotes go through? The asymptotes go through the diagonals of the rectangle. Uh-oh. Okay, this time was a little bit better. It doesn't have to be perfect. Okay. And did our graph open vertically or horizontally? It opens vertically. And our vertices are here and here. Remember, they're at 0, 4. Vertices at 0, 4 and 0, 0. So here and here. And we're going to get close to the asymptotes, but never touch them. So this is opening vertically. And this one too. Oh. Here we go. As practice, I'll let you graph the foci, transverse axis, conjugate axis, and lattice rectum on your own. But let's move on to the next example. Sometimes they won't give you the equations in standard form. So this is standard form. This is what we're used to seeing. But if they give you an equation that's not in standard form, then you have to convert it to standard form. In general, whenever dealing with something that looks unfamiliar, try to convert it to something that looks familiar, like in general with math. Okay, so how do we go from this to standard form? Well, we need to complete the square. So I'm going to copy this equation real quick. Okay, so 9x squared minus 16y squared plus 54x plus 64y minus 1 equals 0. Do you remember how to complete the square? So we need to get the x's together and the y's together. So I'm just going to change the order in which we add and subtract here. Oops, 64y. Okay, so now the x's are together and the y's are together. So we can factor. So factor out this. What's positive 54x divided by 9? That's going to be how many x? 54 divided by 9, that's 6. So 6x. Okay, let's do the same thing with y. Okay, so minus 16 times y squared. And then what's this? Positive 64y divided by negative 16. Negative 4y. Okay, so this is starting to look a little bit closer to standard form, because now at least we have parentheses in our equation, but we need to get that squared, the squared term. Squared term? Did I just say squared term? We just need to get something squared for x and y. Okay, so how do we do that? Okay, so now we're ready to complete the square. And to do that, take half of this number. So what's half of 6? So half of 6 is 3. And then we're going to square 3. So 3 times 3 is how much? Sorry about that. 3 times 3 is 9. Okay. And I'm just going to rewrite this as plus 9 minus 9. So I'm rewriting this like this. And you'll see why in a second. Let's go ahead and do the same thing with y. Actually, as an exercise, I'll have you pause the video and repeat my steps with y. Did you get it? Okay, here it is. So plus 4 minus 4. Okay. Minus 1 equals 0. Now, I'm going to move this outside the parentheses. So what's 9 times negative 9? Nine times negative 9 is negative 81. I'll have you pause the video and repeat my steps with y. Okay, let's see what you got. Y squared minus 4y plus 4, and then it's negative 16 times negative 4. So that's going to be a plus 64. Okay. And now, what does this simplify as? So you remember that 3? Since we have positive 3, it's going to be 9 times x plus 3 squared. Okay, and I'll keep this here. How about this one? You should have gone negative 2. Okay. Now we can combine this, this, and this. So what's negative 81 plus 64 minus 1? Okay, so let's see. So this plus this is negative 17 minus 1 is negative 18. And let's add 18 to both sides of the equation. Why am I adding 18 to both sides of the equation? Well, here I'll show you. Notice here you only have x minus something squared, y minus something squared. There's nothing else over here. But we have something extra here, so we just move it to this side. Okay, so let's add 18. And then what's different from here with the equations that are in standard form? We have 18 instead of 1 on the right-hand side. So how do we change it to 1? Divide both sides of the equation by 18. How do we simplify this fraction? We can divide out 9 on the top and bottom. So 9 divided by 9 is 1, and 18 divided by 9 is 2. So this fraction becomes 1 times this, So x plus 3 squared over 2. How about here? Okay. So this is going to be, this is going to be 8. Okay, we're very close. What's the only thing that's off? The only thing that's off is that there's an 8 next to y. So how do we get rid of it? We can multiply the top and bottom of this fraction by 1 over 8. Okay, so what does this become? So now this times this is equal to 1. That's why I multiplied by 1/8. Okay. Yeah, this turns into 9 over 8. Okay. So we finally converted it into standard form. Now it looks like this. All right. So I'm going to copy it real quick. Okay, and does this open horizontally or vertically? Since x is in front of the minus sign, it's going to open horizontally. What's the center? So multiply this by -1, so -3, and I multiply this by -1, so 2. This is with x, so I use -3 as my x coordinate, and I use 2 as my y coordinate. How do we find the vertices? So we need to find a, and how did we find a again? It's the square root of this number. So √2. Okay, and since x is in front of the negative sign, are we going to be changing x, or are we going to be changing y? Since x is in front of the negative sign, we need to change x. So what did we do with h and a? We added them, and we also subtracted them. This is your answer. How did we find the foci? So use the formula c equals square root of a squared plus b squared. Okay, and what are a squared and b squared again? So this number is a squared, and this number is b squared. Okay, so this turns into square root of 2 plus 9 over 8. I'll just write it here. So how do we convert this into an improper fraction? 2 is equal to how much divided by 8? 2 is equal to 16 divided by 8. Okay, I need to make this square root a little bit bigger. Okay, now they have a common denominator. What's 16 plus 9? 25. How do we simplify this radical? So I can rewrite it as √25 over √8. What's the square root of 25? 5. And how do we simplify the square root of 8? We need to rewrite it as square root of 4 times square root of 2. The reason why I picked 4 is because it's the largest perfect square that evenly goes into 8. That's not 1. And square root of 4 is just 2. Yeah, so you just need to make sure that this is a whole number. Okay, we still have a problem here, and it's that we have a radical in the denominator. So we need to rationalize the denominator here. How do we do that? How do we get rid of the radical in the denominator? We can multiply the top and bottom by it. So 5 times root 2, that's just 5 root 2. And then this becomes 2 times root 2 times root 2. And what's root 2 times root 2? That's just 2. Okay. What's 2 times 2? Okay, so that's what c is equal to. 5 root 2 over 4. Okay, and what do we need to do with c? We need to add it to h for a horizontal hyperbola. So negative 3 plus 5 root 2 over 4, 2, and we're also subtracting it. This is your answer. How do we find the transverse axis length? The transverse axis length is 2 times a. So 2 times root 2. The conjugate axis is 2b. And how do we find b? Well, b squared, I'll write it here. B squared is equal to 9 over 8. So what do I do to both sides of this equation to get b by itself? Take the square root. So square root of b squared is just b, and then I need to take the square root of this. As practice, I'm going to let you pause the video and simplify this radical. Yeah, you just need to repeat my steps here. Okay, so this is going to be, let's see, so it's going to be 3 over 2 root 2, and then we rationalize the denominator. Okay, and this is going to be 3 root 2 over 2 times 2, which is 4. Okay, so b is equal to this. So 2b is equal to 2 times this, times 3 root 2 over 4. What can we do to simplify this? Cancel. So divide out 2 and then divide out 2. Yeah, so this is going to change to 2, and this just becomes 1 times 3 root 2 over 2, which is just 3 root 2 over 2. This is your answer. What's the formula for lattice rectum length again? 2b squared over a. Okay. So what's b squared? B squared was 9 over 8. So 2 times 9 over 8 over a. And a was how much? Root 2. Okay, so we need to simplify 2 times 9 over 8 over root 2. So as practice, I'll let you pause the video and simplify this part. You just need to repeat my steps. Wait. Yeah, you just need to repeat my steps like what I did here. Okay, so the top is going to become 9 over 4, and then we're dividing by root 2. So this is going to become 9 over 4 root 2. And how do we rationalize? We need to multiply the top and bottom by this. So it becomes 9 root 2 over 8. Okay, so that's what this simplifies to, 9 root 2 over 8. What was the formula for eccentricity? C over A. Okay, and what was C again? 5 root 2 over 4. Okay, and then, so C divided by A. So I don't have enough room here. I'll just put a divide by sign. And then A was root 2. Okay, let's see here. Sorry. I'll get another sheet of paper and simplify this. So 5 root 2 over 4 divided by root 2. So that's the same thing as times 1 over root 2. What can we simplify here? We can just cross out the root 2's. Okay, so this just becomes 5 times 1, 5 over 4. So the eccentricity is 5 over 4. How do we find the asymptotes? Okay, so with the horizontal hyperbola, the formula for asymptotes is, here I'll just use the other sheet of paper. It's y equals b over a times x minus h plus k, and y equals negative b over a times x minus h plus k. So we just plug in a, b, h, k into here. Yeah. So what was a again? A was root 2. Okay, I'll just do this. Wait, we need to put in b first. I'll just put the a here. A is root 2. B was how much? It's this. Oh, you guys can't see it. B is this over here, 3 root 2 over 4. Okay, times x minus h. How did we find h again? So this is h. You go to the center, this is h, this is k. Okay, plus k. Okay, I'm going to simplify this real quick. What does this simplify as? Okay, and then we can just cross out. So 3 times 1 is 3 over 4. That's what this becomes. I'll just write it here. And then subtracting negative 3 is the same thing as adding 3. And you'll notice the only difference between the first line and the second line is what? We need to stick a negative sign in front. Okay, so these are your asymptotes. Do I have enough room to write them here? I think so. Y equals 3 over 4 times x plus 3 plus 2, and y equals negative 3 over 4 times x plus 3 plus 2. This is your answer. As practice, I'll let you graph this on your own. If you made it to the end of this video, you now have a solid understanding of hyperbolas. Also, this is my first 1 hour long video, so let me know how I did in the comments, and if I should continue to make more of these. Alright y'all, thank you for watching, and take care.